In this next activity, we start off with a given triangle, triangle ABC, as shown in the diagram below. We're asked to draw a triangle DEF, whose sides are twice as long as the sides in triangle ABC. I'm going to start off by labeling my diagram here. This is going to be triangle DEF, and the corresponding side to side DF in triangle ABC is side AB. And I'm going to double that length, so that means that this length here for DE is going to be 6 centimeters. The corresponding side to side EF in triangle DEF is going to be BC, and that means that EF is going to be 8 centimeters, double 4. And finally, side FD is corresponding to side CA. CA is 5 centimeters, making DF 10 centimeters. We're asked, how do we know that these two triangles are similar and they're not congruent? Well, for two triangles to be congruent, not only do the corresponding angles have to be equal, but the corresponding sides also have to be equal in length. And we can clearly see that the sides in triangle ABC are not the same as the side lengths in triangle DEF. We know that these two triangles are similar because the ratio of corresponding sides is the same all the way across. That's how we drew it. We know that the sides in triangle DEF are twice the length of the sides in triangle ABC. And this brings us to the scale factor or ratio. And the scale factor or ratio is simply the measure of the amount of enlargement or reduction that relates one similar triangle to another. And in this case, we know that the scale factor is 2 because the length of the sides in triangle DEF are double the length of the sides in triangle ABC. In the two triangles above, the scale factor is 2. This means that the length of the sides in triangle DEF are twice the length of the sides in triangle ABC. When we calculate the perimeter of triangle ABC, we know that the side lengths are 3, 4, 5. And adding those up together, we get 12. And in triangle DEF, we know that the sides are double those lengths. So that's going to be 6, 8, and 10. And when we add those up, we get 24 centimeters. And we can see that the perimeter of similar triangles is also scaled by that same scale factor, n. And in this case, n equals 2. Now, let's take a look at the area. So to calculate the area of triangle ABC, we know that for any triangle, the area equals 1/2 base times height. Putting in what we know, we'll let AB represent the height, which is 3. So we have 1/2 times 3, which is the height, and the base is going to be 4. So it's going to be 4 times 3. Doing some quick calculations, we can see that the area is going to be 6 centimeters squared. Now, the area of triangle DEF will do the same thing. Area equals 1/2 base times height. And in this case, we know that the height is going to be 6 centimeters and the base is going to be 8. So it's going to be 8 times 6. All right. Dividing 2 into 8, we get 4. 4 times 6 is 24. So we can see that the area is going to be 24 centimeters squared. Now, that looks like the area is 4 times larger. But remember, our scale factor was n equals 2. So we could say that the area of similar triangles relate to each other by a factor of 2n. But, see, 2 is a crazy number. It could also mean that they relate by n squared. So let's do a little bit further calculation here, and let's see if we can actually figure out what has happened here. So let's see if we can figure out what is really happening. Let's take a general case where two similar triangles have a scale factor of n. Okay? To find out the area, the first one is just simply going to be 1/2 base times height. And it really doesn't matter what the base and height are. For the scaled triangle, the area is going to be 1/2 times the base of this new triangle. And remember, we got the base of this new triangle by multiplying the length of the side by n times the height. And the new height is going to be the old height times the scale factor, n again. So let's do some simplification here. What I'm going to do is I'm going to bring n out of this factor, and I'm going to bring n out of this factor. So in other words, I'm bringing n squared out. Now that we factored n squared out, we can actually see that the area of similar triangles relates to each other by a factor of n squared and not 2n. So in summary, the length of any side in triangle DEF is n times the length of the corresponding side in triangle ABC. The perimeter is n times the perimeter in triangle ABC. And finally, the area is n squared times the area of triangle ABC. A drawing of a triangle road sign is made to a scale of 1 to 20. So in other words, the scale factor is 20. The drawing of the sign has a perimeter of 30 centimeters and an area of 50 centimeters. What's the actual perimeter? Well, we already figured out that the perimeter of the similar triangle is going to be n times the perimeter of the original triangle, or of the smaller triangle. So since the smaller triangle has a perimeter equal to 30, then we know that the larger triangle is going to have a perimeter equal to 30 times that scale factor, and that scale factor is 20. When we multiply this out, we end up getting 600, and the units we're using here are centimeters. Now we're asked to find out what the actual area of the sign is going to be. Well, the scale drawing has an area equal to 50 centimeters squared. And we know that the actual sign is going to have an area that is n squared times bigger than the drawing. So the drawing was 50 centimeters squared, and n is 20, so that's 20 squared. Now we just have to do some quick calculations. We're going to have 50 times 400. 4 times 5 is 20, and we've got 3 more zeros kicking around. So that's 20,000 centimeters squared. All right, let's take a look at another question. So we're told that triangle ABC is similar to triangle DEF. That means that there is a scale factor from one side to the next, and all we really need to do is figure out what that scale factor is. From this diagram, it looks like side AB and side DE are corresponding sides. So let's write down that ratio. We're going to have 10 over 21. Now I'm writing my ratios in this order, using triangle DEF and the corresponding sides as the numerators, and using triangle ABC and its corresponding sides as the denominators. We need to make sure that when we're writing our ratios that we keep them in the same order. Now, what we want to do is we want to use the two corresponding sides that have the unknown in it. So here's the two sides that we're going to be using, and we have to start off with triangle DEF, so we're going to put 14 over side BC, which is x. So here's the relationship that we're going to use to solve for x. We can do that by cross multiplying. We're going to multiply 21 times 14, and we're going to multiply 10 times x. So let's do that. We end up getting 10x equals 21 times 14. Well, 21 times 14 is just 294. Now all we have to do is divide both sides by 10, and we've calculated x to be 29.4. And in this case, the units are centimeters. All right, in this last question, we're given the diagram below and we're asked to determine the measure of A. Well, to solve this, we're going to use similar triangles, but before we can do that, we actually have to show that these two triangles are similar. So there's a number of different ways to do this. What we're going to do is we're going to use the properties of parallel lines that are cut by a transversal. And we know that corresponding angles, so if we take a look here, we have an F pattern right here. So there's the parallel line, there's the other parallel line, and it's cut by this transversal right here. And that tells us that this angle right here is going to be equal to this angle right here. And we can do the same thing on the other side. If our parallel line is going to be here, and parallel line is going to be here, and this is going to be our transversal this time, then the corresponding angles in this case are going to be here and here. So now, this angle here is common to both of the triangles. Let me just draw those triangles for you. So we have the upper triangle, and we have the larger triangle. Okay, and in the diagram, this triangle, when it goes on here, it sits right across like that. Okay, so let's just get rid of that for a second. But we know that this angle right here, from our properties of parallel lines, is going to be equal to this angle right here. We also know that this angle right here is going to be equal to this angle right here, properties of parallel lines. And we also know that this angle up here is common to both of the triangles. So because these two triangles have all the same angles, then these two triangles have to be similar. Now this triangle here is triangle, we'll start up here and we'll work around clockwise. So this could be triangle AED, and we can say is similar to triangle, and we start again at A, down to C, and over to B. So now we know that triangle AED is similar to triangle ACB. And we can use the information that's given here and what we know about similar triangles to solve for A. And here's A right here. The other thing I want to do before we actually start solving this is actually put our lengths on here. So we know that this is 18 centimeters, and we know that this is A right here. And we also know that this length is going to be 18 plus 12, which is going to be 30 centimeters. And the bottom length here is 25. And that's all we really need to do. We are going to use our similar triangles, and the corresponding sides here that are length 18 and 30 are going to be our first ratio. And then we're going to use A and 25, which are corresponding sides as well too. And now that we're all set up, all we have to do is some cross multiplication and we can solve. So I'm just going to move the 25 up and over to the left. So we're going to get 25 over 18 times 30 is going to equal A. Now you can go ahead and multiply this out if you want, but I suggest that you start off by reducing. I know that 6 can go into 35 times, and it can go into 18 3 times. I also know that 5 can go into 25 5 times. And what we're left with is 5 times 3 is 15. A is going to equal 15. That's a whole lot easier than multiplying 25 times 18 and then having to reduce afterwards. All right, it's time to move on to today's homework worksheet.